Hello everyone, and welcome to this video where I'll be completing the May 2019 Higher Tier Paper 1 Non-Calculator. Just like any maths paper, it's important that you show all you're working out. Remember, in maths there's always more than one way to get a solution. I'll be choosing the most simplest way, so don't worry if it's a different method. What is important is that we get the correct answer with the correct working out. So let's have a look at question 1. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red cubes in the box is the same number as the number of yellow cubes in the box, and we're asked to complete the table. Firstly, remember the sum of probabilities of all possible outcomes is 1. So when we sum these probabilities, we know it will equal 1. Now, given the fact that we know red and yellow are the same, I'm going to label each one as x, and I'm going to sum them up to equal 1. Now I'm simply going to simplify to give me 2x plus 0.2 is 1. And now I know 2x must be 0.8. So therefore, I know the probability of red is 0.4 and yellow is 0.4. Just as a double check, we can sum them up and we know it equals 1. Now the second part states that there are 12 blue cubes in a box. Work out the total number of cubes in the box. Well, if we know there are 12 blue cubes and we know the probability of a blue is 0.2, therefore we know 0.2 is represented by 12 cubes. So looking at red, what would 0.4 be represented as? Well, if 0.2 is 12 cubes, 0.4 would be 24 cubes. And given we know the probability of yellow is the same as red, therefore we know red is 24 cubes too. So in total we have 60 cubes. For question 2, it states Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter as sugar. Dion's going to make 60 biscuits, and we're asked to work out the amount of flour she needs. Well, let's summarize the information we have here. We know for 15 biscuits, she needs 50 grams of sugar. Now for flour, she uses 3 times as much flour as sugar. So that means she uses 150 grams of flour. For butter, well, she uses 2 times as much butter as sugar. So that means she uses 100 grams of butter. Now, given the fact that she wants to make 60 biscuits, what do we have to do to our recipe for 15 to make 60? Well, we simply multiply by 4. So that means we multiply each one of our quantities by 4 as well. Now we're only interested in flour, so we're just going to multiply our 150 by 4 to give me 600 grams. Now Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. We're asked how many packs of butter does Dion need to buy? Well, remember for 60 biscuits we need to multiply by 4. So, given 15 biscuits is 100 grams of butter, multiplying this by 4 gives us 400 grams of butter. So that's how much butter she needs to make 60 biscuits. Well, if we know she only buys them in 250 gram packs and we only need 400 grams, it's clear that she only needs 2 packs. Question 3 wants us to find the highest common factor of 72 and 90. Now, a nice little way to do this is to identify the prime factors of each number and put them in the Venn diagram. Remember, there's more than one way to get the solution. I like this method as it's quite visual. To find the highest common factor, you multiply all the prime factors in the intersecting area here. To find the lowest common multiple, you multiply all the prime factors found in both of our circles. Now, given we want the highest common factor, we need to multiply all our prime factors in this intersecting area. So, identifying my prime factors of 72 gives me 2 times 2 times 2 times 3 times 3. And identifying all my prime factors of 90 gives me 2 times 3 times 3 times 5. Inserting these into my Venn diagram, you can see I have all my prime factors of 72 here and all my prime factors of 90 here. Noticing how I have common prime factors which I've put in this intersecting area. So that means the highest common factor is 2 times the 3 times the 3, which is 18. Now question 4 states that the diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimetre grid. We're asked to draw a sketch of the solid shape, giving dimensions of the solid in our sketch. Now it's important to remember what these keywords mean. So remember, a plan view is a view from above. So this is what we see if we're floating above the shape and looking straight down. A front elevation is the view if we were standing directly in front of our solid. And the side elevation is the view that we would get from our solid if we were standing to the side. So it might be easy for you to recognize now that the solid must be a cylinder. So when you draw your cylinder, it doesn't have to be a work of art. But what is important is that we state our dimensions, counting the squares carefully from our grid. Well, you can see that the height of the cylinder is given here from our front elevation. So we can see it's 1, 2, 3, 4, 5 centimeters in height. Now the diameter of our solid is given by our plan view. So you can see the diameter must be 1, 2, 3, 4 centimeters. So don't worry about your sketch. It doesn't have to be a work of art, but what is important is that you pull the dimensions from your grid. Moving on to question 5, it shows shape A can be transformed to shape B by a reflection in the x-axis followed by a translation CD. We're asked to find the value of C and the value of D. So from the question it's clear that we have to reflect in the x-axis. Now remember the keyword translation. Well, a translation is a movement. Remember we use a vector to instruct this movement. The number on the top indicates if we're going left or right. The number on the bottom indicates if we're going up or down. Remember, if the number on the top is negative, we're going left, and if the number on the top is positive, we're going right. If the number on the bottom is positive, we're going up, and if the number on the bottom is negative, we're going down. So let's start reflecting in the x-axis first. Well, I suggest plotting each point carefully. So I'm going to plot this point first and reflect it in our x-axis. Carefully, counting 2 squares directly down, you can see my new point will be here. Plotting this point from my x-axis gives me my new point here. And plotting my last point here, you can see counting from my x-axis means my new coordinate would be here. So this is my new reflected shape. Now what I have to do is identify the vector for when I move the reflected image to shape B. So you can pick any corresponding corner. I'm going to pick this one. So counting carefully and noting the direction, I've gone 1, 2, 3, 4, 5, 6 to the left and 1 down. I'm just going to check with another 1, 2, 3, 4, 5, 6 and 1 down. And lastly, I'm going to check with the last one. 1, 2, 3, 4, 5, 6 to the left and 1 down. So remember our vector, 6 to the left would indicate a -6 and 1 down would indicate -1. Question 6 states a shop sells packs of black pens, packs of red pens and packs of green pens. There are 2 pens in each pack of black pens. There are 5 pens in each pack of red pens. There are 6 pens in each pack of the green pens. Now on Monday, we know the number of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold was 7 to 3 to 4. Now we also know the total number of pens sold was 212. And we're asked to work out the number of green pens sold. Now it's important to notice the difference between the individual pens and the number of packs sold. So looking at the ratio, we know it's in the ratio of black to red to green. So let's look at the individual pens sold. Well, for black pens sold, we know this represents the number of packs. And we know there's 2 pens per pack. So I'm going to multiply the 7 by 2. The 3 represents the number of red packs sold. So if I know there's 5 pens in each red pack, it's 3 times 5. The 4 represents the number of packs of green pens sold. And I know there's 6 pens in each green pack. So 4 times 6 is the number of green pens sold. So now I've worked out how many parts each colour was sold. Now, given the fact that I know there are 212 pens in total, let's add up the total parts. 14 add 15 add 24, which is 53. And that makes 212 pens. So, working out one part, I know one part represents 4 pens. Now, given the question wanted me to find out the number of green pens sold, well, I know there's 24 parts that represent green pens. So, it's 24 multiplied by our 4, which is our 96 pens. In this question, it was really important that you notice the difference between packs and the individual pens sold. Question 7 shows us 2 rectangles. We have rectangle ABCD and rectangle PQRS. Now it states that QR is equal to 10 centimeters, BC is equal to PQ, and the perimeter of ABCD is 26 centimeters, and the area of PQRS is 45 centimeters. We're asked to find the length AB. Now, a nice little tip for these types of questions is just do one sentence at a time when you're given this type of information. So let's label what we have. We know QR is 10 centimeters, which I've labeled here. We know BC is equal to PQ. So I'm just going to label BC as X, and I'm also going to label PQ as X. Now the perimeter of ABCD is 26 centimeters. Well, that means I can label this length, let's say Y. So I'm going to label this length Y, and I know this length is X. So let's use the information we have so far. Well, if the perimeter of ABCD is 26 centimeters, I'm going to write an equation. I know if I were to sum up all of these lengths, it would give me 2x plus 2y, which is 26. Now, it says the area of PQRS is 45 centimeters. Well, to find the area of a rectangle, I know it's length times width. So that means 10 times the x must be 45. So now I have some equations, and we can solve this one. If I know 10x is 45, therefore I know x must be 4.5. Because I know x is 4.5, I can pop this back into my first equation. So that means if x is 2.5, 2 times 2.5 is 9, add our 2y. Subtracting our 9 gives me 2y equals 17, so therefore I know y is equal to 8.5. Given the question wanted me to find AB, I know I labelled AB to be y, so that means AB is 8.5. Looking at question 8, it states that we need to work out an estimate for the value of root 63.5 multiplied by 101.7. Now remember, whenever we estimate, we always round each number to one significant figure. But here we're given a square root, so it's important that we use our knowledge on square numbers and finding the closest square number. So I'm going to round this to 64 and round this to 100, because I know 64 and 100 are square numbers because we have a square root. Well, using our laws of Surds, I know that this is equal to the square root of 64 multiplied by the square root of 100, which is 8 times 10, which gives me an answer of 80. This is probably the easiest way in which you can get a solution. However, it is important to note that the mark scheme does allow any answer in between 75 and 81 as long as you've shown you're working out clearly and correctly. Let's have a look at the next question. It says 2.3 to the power of 6 is equal to 148, correct to 3 significant figures. We're asked to find the value of 0.23 to the power of 6, correct to 3 significant figures. Well, what's important to note is that we understand what 2.3 to the power of 6 represents. Well, it means this. 2.3 is multiplied by itself 6 times, which equals our 148. What's also important to note is what 0.23 to the power of 6 represents. Well, we know it's 0.23 multiplied by itself 6 times. So let's find the relationship between what the examiner gave us and what we're trying to work out. Well, we know looking at 2.3, to give 0.23, we have to divide by a 10. And for this 2.3 to give 0.23, we divide by another 10. So what we can see is, using what we were given in the exam, we divide each one of our 2.3s by 10 to give us each of our values. So that means we must do 148 divided by 10 to the power 6. This then gives us 0.000146. Now for C, it asks us to find the value of 5 to the power of minus 2. What's important to remember is you need to know your laws of indices, in particular this law, where a to the power of minus x is equal to 1 over a to the x. These are important laws for you to remember. So that means 5 to the power of minus 2 is 1 over 5 squared, which gives us the value of 1 over 25. Now looking at question 9, it wants us to work out 3.5 times 1 3/5. We must give our answer as a mixed number and in its simplest form. Now what's important to note is we need to convert our mixed numbers into improper fractions. And remember, to do this, it's very simple. We multiply the whole number by the denominator and add the numerator. So 3 times 2 add 1 is our 7 over the 2. 1 times 5 add our 3 is our 8 over 5. Remember, with multiplication, it's super easy. 7 times 8 is our 56, and 2 times 5 is our 10. Now we need to convert it back into a mixed number. So how many 10s go into 56? Well, we know it's 5, remaining 6 over 10. Now, because the question wants us to write it in its simplest form, we can see the final answer must be 5 3/5. Now looking at question 10, the graphs with the equation 3y plus 2x is equal to half, and 2y subtract 3x is equal to minus 113 over 12 has been drawn on the grid. Now it says, using the graphs, find estimates of the solutions of the simultaneous equations given here. Well, remember, whenever we're asked to solve simultaneous equations with graphs, it's very simple. All we need to do is find out where these graphs or functions intersect. So we simply find the point of intersection and identify the coordinate. So looking at our x value, we can see the x value reading to the point of intersection for me is 2.25. And the y value reading across to the point of intersection gives me minus 1.3. Now your values don't have to be exactly the same as mine, as the mark scheme does state it will accept any value in between 2.2 and 2.3 for the x, and minus 1.3 and minus 1.4 for the y. Now let's have a look at question 11. Question 11 states a bus company recorded the age in years of people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. We're asked to complete the table to show the information about the ages of the people on coach A. Now we're asked to work out the median, lower quartile and upper quartile. So let's have a look at the median first. Now remember, when you're working out the median of listed data, to find the position of where the median lies, it's the number of data values, add 1, divide by 2. And this gives us the position of the median. So we know there's 23 pieces of data, add 1, divide by 2, so the median is in the 12th position. Counting carefully along in order, let's find the 12th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that means the median is 59. Now let's have a look at the lower quartile. Well, the lower quartile is when you sum the number of data values, add 1, divide by 4. And remember, this gives you the position. We know there are 23 data values, add 1, divide by 4, so we know the lower quartile is in the 6th position. So let's count. 1, 2, 3, 4, 5, and the 6th position is 53, so this is my lower quartile. Now for the upper quartile, it's simply 3n, add 1, divide by 4, which gives us the position. So we know 3 times 23 add 1 divided by 4 is the 18th position. A nice little trick is simply to multiply the lower quartile position by 3. So counting carefully to our 18th position, this will give us the upper quartile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18, which is 66. Now, the second part of the question states that we're given some more information about the ages on a different coach, Coach B. Richard said that the people on Coach A are younger than the people on Coach B. Is Richard correct? And we must give a reason for our answer. Well, Richard is correct, because the median age of Coach A is 59 years old and the median age of Coach B is 70 years old. So the average age on Coach A is younger than Coach B. You can get any mark here as long as you're making a comparison with averages. Now, the second part states that Richard says the people on Coach A vary more in age than the people in Coach B. Is Richard correct? You must give a reason for your answer. Well, no, he's not correct, because the age range from Coach A is 79 subtract our 41. In other words, our greatest value subtract our least value, which is a range of 38 years. And the range on Coach B is 85 subtract our 42, which gives us an age range of 43 years. So that means it shows that the age range on Coach B is wider than the age range of Coach A. As long as you say no and make an accurate comparison of spreads of ages using interquartile range or the range, you will receive your mark. So now let's have a look at question 12. Here are 3 spheres. The volume of sphere Q is 50% more than the volume of sphere P, and the volume of sphere R is 50% more than the volume of sphere Q. We're asked to find the volume of sphere P as a fraction of the volume of sphere R. Well, what's important to note is when we're talking about an increase, remember the calculation when we increase by a percentage is the amount multiplied by 1 plus the percentage as a decimal. So, if we're identifying a 50% increase from sphere P to Q, we simply multiply the volume of sphere P by 1.5, and this is our 50% increase, indicated by this expression. Now, if we're increasing the volume of sphere Q by 50%, therefore this is indicated by this expression. So you can see I've multiplied by 1.5 and 1.5 to indicate an increase of 50% here and an increase of 50% here. Now, because it's a non-calculator exam, I'm simply going to write this using fractions because it's a little bit easier. The volume R is given by the volume of P multiplied by my 3 over 2 by my 3 over 2. Remember, these are equivalent to 1.5. Working this out, well, that means I know the volume of sphere R is 9 over 4 the volume of sphere P. But the question wants me to find the volume of sphere P as a fraction of volume of sphere R. You'll notice I've done it the wrong way round here. So I'm simply going to rearrange to give me the volume of sphere P is 4/9 the volume of sphere R. So therefore, I know the volume of sphere P as a fraction of the volume of sphere R is 4 over 9. Question 13 says, given that n can be any integer such that n is greater than 1, we need to prove that n squared subtract n is never an odd number. Well, let's have a look at n squared subtract n in its factorized form. This would be n bracket n minus 1. Now, let's look at n being an even number. Well, if n is an even number, this would be indicated here. Now, if n is even and we subtract 1, then that would be odd. And we know any even number multiplied by an odd number will always be even. Now let's have a look when n is odd. Well, when n is odd, it's fair to say this would be odd. An odd number subtract 1 will always be even. And that means we know any odd number multiplied by an even number is always even. So that means we know n squared minus n can never be odd. Now let's have a look at question 14. We're asked to find the exact value of tan 30 multiplied by sin 60, giving our answer in its simplest form. One top tip is to memorize these trig equivalents. In other words, know sin 30 is equivalent to 1/2, sin 45 is equivalent to 1 over root 2, and sin 60 is equivalent to root 3 over 2, so on and so forth. So let's have a look at this question. Well, we know tan 30 is equivalent to 1 over root 3, and we know sin 60 is equivalent to root 3 over 2. So working out tan 30 multiplied by sin 60 is simply root 3 over 2 multiplied by 1 over root 3. This gives me root 3 over 2 root 3. Now, because you can see we have root 3 in the numerator and a root 3 in the denominator, we can cancel down. So this gives me a nice fraction of 1/2. So therefore, my answer is 1/2. Now let's have a look at question 15, where it shows a diagram of a solid shape. The shape is a cone on the top of a hemisphere. The height of the cone is 10 centimeters, and the base of the cone has a diameter of 6 centimeters. It says that the hemisphere has a diameter of 6 centimeters. The total volume of our shape is k pi centimeters cubed, where k is an integer, and we're asked to work out the value of k. So, first things first, let's work out the volume of each part of our entire shape. Let's start with the volume of our cone. It's nice that the examiner has given us the formula, and it states that the volume of the cone is 1/3 pi r squared h. So let's substitute what we know. Well, from our diagram we can see that the radius is 3 and the height is 10. So working this out, we've got 1/3 pi times our 9 times our 10. Now remember, this is a non-calculator exam, so we have to work it out. 9 times 10 is 90, and 1/3 of that 90 is 30. So therefore, my answer for the volume of the cone is 30 pi, making sure you do leave it in terms of pi. Now let's have a look at our hemisphere. The examiner has given us the volume of the sphere, but don't forget to divide it by 2 because it's a hemisphere. So it's 4/3 pi r cubed divided by 2. Now, looking at our diagram, you can see that the radius is 3, so substituting this in. Working out what we can, this gives us 4/3 pi times 27 divided by 2. So let's take our time when we're working this out. 27 divided by 3 is 9. 9 multiplied by our 4 is 36, and then this divided by 2 gives us 18 pi. So now we know to work out the volume of the entire shape, it's the volume of the cone add the volume of the hemisphere, which is 30 pi add our 18 pi. Working this out, this gives me a final answer of 48 pi. So therefore, k must be 48. Moving on to question 16, it says there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, and 5. The 3 digits 553 is one way that the dials can be set as shown in the diagram. We're asked to work out the different 3-digit numbers that can be set for the combination lock. Now remember, there are 3 different numbers that we could pick. So we can pick any number between 1 and 5 on our first pick, any number between 1 and 5 on our second pick, and any number between 1 and 5 on our third pick. So we have 5 options to choose from on our first pick, 5 options to choose on our second, and 5 to choose on our third. So that means the total number of combinations is 125. Now part B states how many possible 3-digit numbers have 3 different digits. Well, remember, we have to choose 3 numbers. In our first pick, we can choose any one of our 5 numbers, but for our second pick, one of those numbers has been chosen, and we're not allowed to use that same number again. It has to be different. So that means we only have 4 numbers to choose from. And our third pick, well, because we've used 2 previous numbers, that means we only have 3 numbers to choose from. So this gives us a total number of possible 3 digits with 3 different digits to be 60. given that x squared to 3x plus 5 is equal to the ratio of 1 to 2. We're asked to find the possible values of x. Now remember the nice little trick whenever you're talking about equations and ratio. If you have a ratio of a to b, which is in the ratio of x to y, then to form an equation we simply cross multiply, and this is the same as ay equals bx. So let's identify what we have here. X squared to 3x plus 5 in the ratio of 1 to 2. Let's cross multiply and form our equation. This gives me 2x squared equals 3x plus 5. You'll notice we have a quadratic, so remember the quadratics always equate to 0. This gives us 2x squared minus 3x minus 5. From here, you must factorize. Now there's lots of different ways that you can factorize, but I'm going to use the ACB method, whereby AC is the result of our 2 multiplied by our minus 5, and our B is our minus 3, as I've indicated here. Then we need to think, well, what two numbers multiply together to give minus 10 and add together to give minus 3? Well, the answer is minus 5 and 2. So putting this back into our equation, this means 2x squared plus our 2x subtract our 5x minus 5 equals 0. From here, then I'm going to factorize. This gives me 2x bracket x plus 1. Using this factor of x plus 1 again, that means minus 5 must be here to give me my minus 5x minus 5. Then you can clearly see our factors. We have a factor of x plus 1 and the other factor of 2x minus 5. Now remember we need to find the values of x. So using the factorized form, I know my values of x are x is equal to minus 1 and x is equal to 5 over 2. Question 18 says express root 3 and root 12 in the form of a root 3, where a is an integer. What's important to note about this question is our laws of Surds. Remember the square root of ab is equal to root a times root b. Now for this particular law we can spot that we can split root 12 into two numbers, and it's important to always note your square numbers whenever dealing with Surds. So I'm going to split root 12 into two factors, where one factor is a square number. This means I know 3 plus root 12 is equal to root 3 plus root 4 root 3, because I'm utilizing my laws of Surds and my knowledge on square numbers. Well, I know the square root of 4 is 2. So this means I have root 3 add 2 root 3. Well, if I had 1 root 3 and I had 2 root 3's, therefore I have 3 root 3's. So my answer is 3 root 3. Now part B says express 1 over root 3 all to the power of 7, and we need to give it in the form of root b over c, where b and c are integers. Now remember your laws of indices. In particular, a over b all to the power of n is equal to a to the n over b to the n. So all I'm going to do now is use my laws of indices here. So I know this is equal to 1 to the power of 7 over root 3 to the power of 7. Well, I know 1 to the power of 7 is 1, and I'm just indicating root 3 to the power of 7 here. Now, root 3 to the power of 7, if I were to rewrite all this out, you can see I have 7 root 3's all multiplied by each other. Now we know if we multiply root 3 by root 3, the answer is 3. So these 2 root 3's make this 3, these 2 root 3's make this 3, these 2 root 3's make this 3, and we're left with one single root 3. Working this out, this is the same as 1 over 27 root 3. Now we need to recognize the question wants us to rationalize the denominator. So remember, whenever you rationalize the denominator, you multiply the numerator and denominator accordingly to ensure the denominator is rational. In this case, I'm going to multiply the numerator and denominator by root 3. Multiplying the numerator by root 3 gives me root 3 over 27 times root 3 is our 3. Working this out, we have root 3 over 81. So therefore, my answer is simply B is 3 and C is 81. Question 19 says, given that x squared minus 6x plus 1 is equal to x minus a all squared subtract b for all values of x. We're asked to find the value of a and the value of b. Now what's important to note that this question wants us to complete the square. Even though it doesn't state that it wants us to complete the square, it's important that we recognize the format. So remember, whenever we're completing the square, the coefficient of x squared must be 1 plus bx plus c, and the completing square form is x plus the b over 2 all squared, subtract the b over 2 all squared, add our c. So let's substitute what we have. Well, here you can see our coefficient of x squared is 1, our b is minus 6, and our c is 1. So let's substitute in. X minus our 6 over 2 all squared, subtract our 6 over 2 squared, add our 1. Simplifying a little bit more, this gives us x minus 3 squared, minus our 3 squared, add 1. Working this out, this gives us x minus 3 all squared, subtract our 8. So it's clear that x minus a all squared, the a must be 3, subtract the b, well the b must be our 8. Part 2 wants us to write down the coordinates of the turning point of the function y equals x squared minus 6x plus 1. Now remember, the turning point is always indicated from the completing square format. So we know our x coordinate must be 3 and our y coordinate is minus 8. Question 20 says h is inversely proportional to p and p is directly proportional to root t. Given that h equals 10 and t equals 144 when p equals 6. We're asked to find the formula for h in terms of t. Now, just like before, a nice little tip is simply to do one sentence at a time. So let's have a look at this first sentence. H is inversely proportional to p. Using this notation, I can see h is inversely proportional to p. Replacing the proportionality sign with a equals k, so I know h equals k over p. Substituting that we know p is 6 for when h is 10. So our equation is now 10 equals k over 6. Now we can find our constant k, which is simply 60. This means I've now found my first formula, which is h is equal to 60 over p. Now let's move on to our second sentence, where p is directly proportional to the root of t. Well, using my correct notation, I can see p is proportional to the root of t. Replacing the proportionality sign with an equals a constant, I'm choosing m. Now let's substitute what we know. Well, from the question it says when p is 6, I know t is 144. So I have 6 equals m root 144. I know the square root of 144 is 12, so that means 6 equals 12m. I can work out m now to be a half. So now I have my next formula, where I know p is equal to 1/2 root t. So the question wants me to find a formula for h in terms of t. Well, I know h is 60 over p. I've just worked out p to be a half root t, so I'm going to substitute this in to give me h is equal to 60 over half root t. Now I'm going to simplify, so remember whenever you divide by a half, this is the same as multiplying by 2. So that gives me h is equal to 120 over our root t. Now let's have a look at question 21. The functions f and g are such that f of x is equal to 3x minus 1 and g of x is equal to x squared plus 4. We're asked to find f minus 1 of x. Now this means we're asked to find the inverse of the function x. So a nice little trick is to rename f of x as y. So now I have y equals 3x minus 1. Currently, y is the subject. And because we want to find the inverse function, that means we need to make x the subject. So I'm going to rearrange by adding 1 to both sides and then dividing by 3. So therefore I have x to be the subject, giving x equals y plus 1 over 3. Now remember, this is the inverse function, so we have x plus 1 over 3. Now let's have a look at the second part of question 21, where we're still given f and g are f of x is 3x minus 1 and g of x is x squared plus 4. It's given that f of g of x is equal to 2g f of x, and we need to show that 15x squared minus 12x minus 1 is equal to 0. So let's break this down into parts first and understand what they mean. Well, first of all, f g of x. This means insert g of x into the function f. So here's my two functions f and g, and I need to insert my function g of x as the x value of f. This gives me 3 bracket x squared plus 4 minus 1. So you can see how I've replaced the x value for my function g. Now I'm going to simply expand to give me 3x squared plus 12 minus 1 and simplify, so that means I know f of g of x is equal to 3x squared plus 11. Now let's have a look at the composite function 2g f of x. Well, this means I need to put f of x in as the x values for function g. So here's my two functions, and I need to insert the function f as the x value in g, and not forgetting to multiply it by 2. So that means 2g f of x is 2 multiplied by the f function is now substituted in as the x, so I have 3x minus 1 all squared add 4. Now we have to be very careful here with our brackets, so I'm going to expand one thing at a time, starting with our double brackets. Well, the 2 is still our multiplier, and we need to expand our double brackets, so we have 3x minus 1 bracket 3x minus 1 plus our 4. Now let's expand our brackets. Well, 2 is still our multiplier, and 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. Minus 1 times our 3x is minus 3x, and minus 1 times our minus 1 is plus 1. And then we add our 4. This is becoming a little bit easier now. So now let's collect all like terms to give us our multiplier of 2 outside, bracket 9x squared minus 6x plus 5. Now I can expand to give me 2g f of x to be 18x squared minus 12x plus 10. Now remember, the question said to equate the composite function f of g of x is equal to 2g f of x. So I'm going to equate these two functions. This gives me 3x squared plus 11 is equal to 18x squared minus 12x plus 10. Now I'm going to collect all my terms, subtracting the 3x squared from both sides and subtracting the 11. This therefore gives me 15x squared minus 12x minus 1, which is what the examiner gave me at the start of this question. Now let's have a look at our last question. Here the question says there are only red counters and green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3 over 7. Now the counters put back in the bag, and 2 more red counters and 3 more green counters are put in the bag. And another counter is taken randomly from the bag. The probability that this counter is green is 6 over 13. We're asked to find the number of red counters and find the number of green counters that were in the bag originally. So remember our top tip. Let's do one sentence at a time. Well, we know red counters are represented by R and green counters are represented by G. And we know a counter is taken at random and the probability of a green is 3 over 7. So that means we know the probability of a green is G over the total number of counters, which is R plus G. And we also know that probability is 3 over 7. So what we've just formed here is an equation. So let's have a look at our next couple of sentences. Remember the counters put back in the bag, and 2 more red counters are added, and 3 more green counters are added. And now the probability of a green is 6 over 13. So we know the probability of a green is originally the number of green counters add 3 because we've got 3 more, over the original amount of red counters, add 2 because we have 2 more red counters, the original number of green counters, add 3 because I have our 3 green counters. So this means I have another equation, which I'm going to simplify to give G add 3 over R plus G add 5 is 6 over 13. So I have 2 wonderful equations now. So let's have a look at our first equation, which is G over R plus G equals 3 over 7. I'm going to cross multiply, so 7 multiplied by my G is 7G, and 3 plus R multiplied by my 3 gives me 3R plus 3G. Now I'm going to collect all my like terms, so I have 4G is equal to 3R. This is a nice, easy equation. Now let's have a look at our second equation we formed. We know G add 3 over R plus G plus 5 is equal to 6 over 13. So let's cross multiply again. Well, 13 times our G is 13G, 13 times our 3 is our 39. R times 6 is 6R, G times 6 is 6G, and 5 times 6 is our 30. Now I'm going to collect all my like terms, so I have 7G add 39 equals 6R add 30. Subtracting 30 from both sides give me 7G add 9 equals 6R. Now remember from the equation we had before, we know 3 R's is 4G. So if we know 3 R's is 4G, it's fair to say 6 R's would be 8G. So now we have 7G add 9 is equal to 8G. From here we can solve. So subtracting 7G from both sides means 9 is equal to G. So that means we know we have 9 green counters. Now if we know we have 9 green counters, let's substitute it back into one of our formulas to find out how many red counters there are. I'm going to choose this one. So I know there are 9 green counters, so 4 times 9 is 3R. This means 36 is 3R, so that means I know R must be 12. So I know there are 12 red counters. If you liked this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel so you'll be the first to know when we release our next videos.